Hi everyone. In general chemistry, you will be dealing with numbers a lot in the form of maybe looking up physical properties of molecules in a table, data that you collect, calculations, and measurements. And how you communicate those numbers makes a big difference in how an audience could and should interpret the reliability and the precision of those numbers. Here I have an homage to the Count of Sesame Street, and we'll do these types of problems in a different video. For this video, I want to answer specifically the question, how many digits should I use when recording measurements? That's a very important question when you're taking measurements and dealing with instrumentation and glassware in a chemistry lab. This is one of several videos in Unit 1 of General Chemistry 1 and how to use these numbers and how to treat these numbers. And specifically, we're going to look at recording measurements. Now, let me give you an example of why it's important that we be very careful in how we report numbers. For instance, in 4th century BC, scientists were calculating the distance from the Earth to the Moon, the average distance. And the average distance in some of their measurements was 238,000 miles. Now, when you see that number, 238,000 miles, what what may the audience assume? They may assume that this is an approximation, okay, and that the last number that has any um, definite meaning is this number here, 8. If this is an approximation, a good estimation of what this number really means is 238,000 plus or minus 1,000, meaning that this last digit is an estimation. And I'll go over why we can safely assume that. But for now, let's say there's an error and that the distance from the Earth to the Moon could be 237,000 miles to 238,000 miles. And there's that range. Okay, but with the advent of lasers, okay, in the 1960s, at a certain point in the orbit, they got a number 238,855. And now the last digit where there's a meaning to this distance is 5. Okay. Using this convention where you take that last digit that you know has meaning, okay, and making it plus and minus that unit to show the error, then we would say that this is to the plus or minus to the ones place. So the accuracy is now 238,855 plus or minus 1 miles. Obviously, this number you would say is more precise, and that's because humans had better instruments to measure that distance. But what about when you take measurements? So I do have a couple examples. Okay, here we have a ruler. Here we have a graduate cylinder. Sorry, graduate cylinder. But let me give you a general rule that will be very easy to remember. And that's when you take an analog measurement, so not a digital, but an analog, and where might that happen? Um, if you use a ruler, if you use a graduated cylinder, every digit should be certain except for the last one. And so that's a phrase that maybe you can memorize. Every digit that you record is certain. Okay, you're sure of it, except the last one, going from left to right. And I'll show you an example. The last one, you could think of it as a guess or an estimate. Just say a guess. Okay. Because, for instance, if I have this graduated cylinder of water and I ask 10 people to tell me what volume this is, it wouldn't surprise me if I get several different answers. And there can be many different answers. Let me show you an example. For instance, forget about the ruler and the graduate cylinder. Let's say we have thermometer, and the temperature that I see recorded in a notebook is 78.62 degrees Fahrenheit. Okay. What am I supposed to assume about this number? If the scientists who took this measurement followed this rule, we can assume that they believe, or they are telling us that they are positive about that digit. So this is certain. And this digit is a guess. Okay. The other thing that we can assume is that this last digit, 70, is the guess. And that's why in my previous examples, I made that the error. So the error now is in the hundredth place. So 0.01 degrees Fahrenheit. So that's another way that you can express this number right here if they're using this convention. And you should when you record your measurements. So let's take a look at some specific examples. The first one is two rulers measuring the same candy cane. Okay. Actually, let me give you one more example, and then we'll get to those pictures. What does this mean? Or what kind of thermometer do you think this person used? If, for example, the markings, right, the little hash marks of a thermometer is every 10th place or 10th place. Do you know where that is? That's the 6th, right? The 10th place. This is the ones, this is the 10th, this is the 100th. If, for example, the markings of a thermometer is every 10th place, then report 1 unit past that. Because that place would be the guess. So this is the I think that's a correct English, 100th place. Or you could think of it as 1 over to the right. Okay. Now let's take a look at the ruler. Because knowing that we could use this trick, if we know where the markings are, we just have to go beyond that. What about this ruler here? This top ruler goes to it's centimeters, and it goes to the ones place, right? Every marking is to the ones. Every marking is 1 centimeter. Okay, so we're going to go 1 unit to the right of that. So record to the 0.1 centimeter mark. Okay, have a number in your mind, and you're going to the 10th place. You don't go into the 10th place. I think we all can agree that it's certain that this is at least 4, right? And that's the certain. That's the last certain digit that we know, because that's where, well, the markings are every centimeter. Okay, I have a number in my mind. Get a number in your mind, and I'm gonna say, based on this ruler, this candy cane is 4 point, uh-oh, I say 4.3. Yeah, I'll say 3 centimeters. It wouldn't surprise me if some people said 4.2, 4.4, okay? If I want to report a range, then what would that range be? It would be 4.3 plus or minus what? Plus or minus where are the guesses? The guess is on the 10th place. And don't forget units, okay? This will tell the reader what kind of measuring device you're using and its accuracy, okay? And just as a reiteration, this number was certain, and this number was the guess. And that's why I would accept 4.2 or 4.4. Even 4. Now, well, 4.1 is a little bit iffy. You notice that I don't try to guess 4.35 or 4.33. That's those are too many numerals that are a guess. It's only the last one that should be a guess or uncertain or estimation. Okay? Do you see this ruler down here? Use the trick, understand where the markings are, and then give a recording that goes 1 digit past that. All right? Let me get the number in my mind, and then we could compare. Hopefully you could see the markings. So I'm certain about, okay. You have a number? How many digits are you using? 4.2 certain, and then I have to give one estimate, and I'm going to say 4 centimeters. Okay. Or 4.24 plus or minus 0.01 centimeters. Again, the 2 is certain, the 4 is the estimate, and if I survey 10 people, okay, I would accept numbers like 4.23, 4.21, 4.25, but I would expect every single person to at least say 4.2, right? Because we're past the second hash mark after the 4. Okay, so what were the markings here? The markings were every 10th. If you take a look at over here, 0, that's a 10th, like 0.1, 0.2, 0.3, 0.5, etc. 0.9, 1. So this is every 0.1 centimeters. So you go 1 digit past it. Okay. I don't want to belabor the point. I think you have a good understanding of this. Let me just do the graduated cylinder with you, because when you look at a graduated cylinder, you want to make sure that your eyeball is level with the level of the water. Not only that, you want to make sure you know the direction of counting. We know that the direction goes in the up direction for a graduated cylinder. You're going to see equipment where you actually count from the top going down, but the 0 mark is way down here, okay? And it doesn't say explicitly, but these are milliliters. 3 milliliters, 4 milliliters. So you could see that every mark is not a milliliter. Every single mark is a tenth of a milliliter. A tenth of a milliliter. Okay, let's play that game again. Oh, by the way, once you have your eyeball level with the top of the water level, what you're really measuring is what's called the bottom of the meniscus. It curves downward. We'll call it concave. Okay, and then you're going to see where the bottom of the meniscus lies in terms of your markings. Okay, let's do this and compare. Be careful, right? This is 4.0. Okay, I have 4.56 milliliters. It goes every 10th of a milliliter. I'm going to go to the 100th place. Thermometer. I won't say a word. Go ahead and get your number in your head. Oh, I will say that this is most likely Celsius. Degrees Celsius. Is this tricky? Ooh. That's so close. But let me double check. I know for sure 102, and then my guess is 0.9. Again, this is the certain. And this is the ones place, right? Because every marking is actually 1 Celsius. 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. So this is different than the others. So we only go to the 10th place. The last two examples we went to the 100th place because the markers were every 10th. The last thing I want to mention is that if you have something digital, like a scale, it's a balance, you will record in Notebook all the numbers that you see. Okay, 5.01, and this is most likely grams. Okay. Now, the accuracy of the balance is 5.01 plus or minus 0.01. It's based off that last digit. And don't forget units, grams. Okay. All right, that is all I want to say for this video. How many digits should I use when recording measurements? In the next video, I believe we're going to look at SI units, centimeters, grams down here, okay? And then I think after that, we'll look at, it's called significant figures. But again, this whole unit, most of the videos in this unit will be dealing with how do we treat these numbers properly so we convey what that we convey reliable numbers that can be trusted.